Hello, welcome back to Chapter 13, Part 3, where we're talking about the unit circle. And in this example, we're actually going to use the unit circle to find sine, cosine, tangent. And sometimes it won't be in this problem, but you could also use it for the other three. But we're just going to focus on sine, cosine, tangent of angles that are identified on the unit circle. So one thing I got to do here real quick, because this is bugging me. I just cut and paste the pictures from the book in order to do this, and I don't like when math people do this. I have to put parentheses around all of these. It's just bad form if you don't. So this is the unit circle, or one example of the unit circle. And in class, we're going to talk about how we develop it. I'm just going to review what we will do in class here. The unit circle is broken into angles of rotation that are positive that go from 0 to 360. So I'm going to start here. I'm going to go all the way around the 360 degrees. But I'm not going to show every angle. I wouldn't be able to anyway because I got parts of degrees or whatever it is. Okay, you have an infinite number of angles. What I'm going to do is I'm just going to show the 30s, the multiples of 30s, and 45 and the multiples of 45. Now, we also include 60, but that gets grouped into multiples of 30. So if I start at 0, I go 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and I'm back to 360. Those are the multiples of 30. The unit circle also has listed on it those angles in radians. So 30 degrees in radians is pi over 6. 60 degrees is pi over 3. And you can go all the way around. Every angle that's marked in degrees is paired up with this angle in radians. So we'll be able to see that. It also includes the 45s. So here's 45, which is pi over 4. 90 is 2 pi over 4, which reduces to pi over 2. So then we have 90, 135, 180, and it goes all the way around. 225, 315, 360 again. Okay, so those are the angles that we have. Then what we have are points that are on the unit circle. And what we will do in class, I'm not going to mess with my unit circle because I'm using a permanent marker. I'm using a Sharpie. But if I go from the center to this point, I have a radius of 1. That's why we call it unit. So unit means 1. All right, 1 unit. So 1 centimeter, 1 meter, 1 mile, whatever. And then using the Pythagorean theorem and what I know about special triangles, I can figure out that the distance from here to here, which is the x value, is the square root of 3 over 2. And the distance up, which is the y value, is 1/2. So I go square root of 3 over 2 to the right, 1/2 up. And those proportions give me my 30, 60, 90 triangle that I would have there. And I also go around, here's my 45, 45 triangle. So I go square root of 2 over 2 to the right, square root of 2 over 2 up. And I can do that all the way around for, well, let's just talk about the first quadrant first. So I got that for all of these. Now here's the cool part. All right, let me move this because I'm going to write on it. We know that sine of any angle theta from the last section is going to be the y-coordinate divided by r. Since I'm dealing with a unit circle, r equals 1. So this means that sine of any angle theta is just the y-coordinate. So the unit circle gives me sine for all of the angles that are here. The sine of 30 degrees is 1/2, the y-coordinate. The sine of 45 degrees is square root of 2 over 2. Again, just the y-coordinate. The sine of 60 degrees is square root of 3 over 2. Using that same idea, the cosine of each angle is going to be x over r, but of course again r equals 1. So the cosine of any angle theta is just going to be the x. So all of the x coordinates all the way around are the cosine of the angle that it's next to. The unit circle gives me the sine and the cosine just through the x and the y. Not in that order. Gives me the sine which goes with the y and the cosine which goes with the x. Now, this is a picture that I copied from the book, but if you go to Google Images, you're going to see very similar stuff, right? One thing that we probably should try to include would be the tangents. Tangent is always going to be y divided by x. And of course, nothing, r is not a factor here, all right? So I'm not going to like divide by 1 or anything. Well, how does that help? Well, let's look at this point right here. Let's go back to 30 degrees. The y value is 1/2, so that's going to be 1/2. And the x value is the square root of 3 divided by 2. Notice that for all of these points going all the way around, the denominators for all of them that are fractions is always 2. So all I got to do is multiply by 2 over 2. These 2's are going to reduce. These 2's are going to reduce. So essentially, I just get 1 over the square root of 3, which I need to rationalize, but hopefully you see what I did there. So all I got to do is take the top part of the x value, the y value, and divide it by the top part, the numerator of the x value, and rationalize it. This is going to be square root of 3 over 3. So right here, I write square root of 3 over 3. Square root of 2 divided by square root of 2 is just 1. Square root of 3 divided by 1 is just square root of 3. Now that's quadrant 1, and these give me the tangent. Tangent of 30 is square root of 3 over 3. Tangent of 45 is 1. Tangent of 60 is just square root of 3. That gives me first quadrant. But the cool part is all of the other angles in second, third, and fourth quadrants just use these angles as reference angles. So the reference angle for 150 degrees is 30 degrees. So these coordinates here are exactly the same as these coordinates with one difference. The x is positive here, the x is negative here. But otherwise they are the same. Same thing here for these two. For 210 degrees, 7 pi over 6, and 330 degrees, which is 11 pi over 6, both of these coordinates are the same as what they are for 30 degrees. The reference angle is 30 degrees. Except, again, in this quadrant 3, both the x and the y are negative, and in this quadrant 4, the x is positive, the y is negative. So if you look, these are the same, these are the same, and these are the same, except where the x's are negative or where the y's are negative. So it's not too hard to put it together. If I finish doing all my tangents, this is going to be negative square root of 3, negative 1, and negative square root of 3 over 3. Notice these are the same, these are the same, these are the same, except because the x's are negative, I'm dividing by a negative and getting a negative. This is going to be positive square root of 3 over 3, because a negative divided by negative is a negative. I pointed the wrong one, sorry. This is going to be positive 1, and this is going to be positive square root of 3. And rounding it out for the tangents, this is going to be negative square root of 3 over 3. This will be negative 1, and this will be negative square root of 3. So look at what the pattern is. Now before I do the problems, there's one more thing I need to talk about. What about the 90 degrees? We talk about the reference angle is acute. 90 degrees is not acute. So what about, or 0 for that matter. So what happens on the axes where I've got 0 degrees, 90, 180, or 270, or back to 360? Well, the pattern holds true. The sine is going to give me the y coordinate. So the sine of 0 degrees is 0, and the cosine of 0 degrees is 1. Those things all work all the way around. Sine is the y coordinate, cosine is the x coordinate, so those still work. It's the tangent where it gets a little tricky. Remember that the tangent is the y divided by the x. I'll move it up so you can see it. Y divided by the x. So this is 0 divided by 1, which equals 0. Tangent of 0 degrees equals 0. I'm in radians, so it'll be okay. Tangent of 0, 0 degrees is 0 radians, is 0. Same thing over here. Negative 1, excuse me, 0 divided by negative 1 is also 0. But what about here? I've got 1 divided by 0. Let's see what happens there. 1 divided by 0. I get an error. What about this? What if I do, and I'll put radians in there. Radians is going to be pi over 2. I'm in radians. So I'm going to do tangent of pi divided by 2, and one more time it gives me an error because I'm dividing by 0. So tangent at 90 degrees is undefined, and I know that that's kind of weird. Same thing down here at 270 degrees. Okay, so how do I use the unit circle to quickly find exact values of trig functions? So I'm going to try to put both of these in the screen at the same time. I'll be switching back and forth. Let's find the cosine of 210 degrees, right? So I go around, here's 210 degrees. The cosine is the x value. So cosine of 210 degrees is the x value. The cosine of 210 degrees is just negative square root of 3 over 2. And that's it. You're done. I'll do these and then I'll switch over to the other ones. Sine of 315 degrees. Let's try to get this in screen. So I go around and here's my 315 degrees. Sine is the y value. So 315 degrees is right here. The y value is this in red or pink, whatever you want to call it. Negative square root of 2 divided by 2. Negative square root of 2 divided by 2. You're just reading the unit circle. That's all you got. You've already done the work. This one's in radians. That's not bad. Cosine of 4 pi over 3. Let's find 4 pi over 3. So here's 1 pi over 3, 2 pi over 3, 3 pi over 3 would be pi. 4 pi over 3 is down here. Remember that cosine is the x value. So the cosine of 4 pi over 3 is the x value right here, which is negative 1/2. Let me rearrange this where I can get everything in the screen again. Hopefully you guys can see this. I know it's awkward. What's the tangent of 5 pi over 3? So I just had 4 pi over 3 here. If I keep going, here's 5 pi over 3. Now, if I didn't already do the tangent on my unit circle, I now have to divide. Negative square root of 3 over 2 divided by 1/2. And the 2's are going to reduce out. The denominators of 2's are going to reduce out. Okay? But I've already done that. It's going to be negative square root of 3. I already have it here. And finally, last one, on this example, before we do more examples later, tangent of 180 degrees. I'll move that over so you can see it. Here's 180, I guess you could have saw it. Here's 180 degrees. Tangent is the y divided by the x. 0 divided by negative 1 is 0. So this just equals 0. So that's all there is to using the unit circle. We'll be doing more problems in a little bit.